All right, let's get started. Hi, everyone. I'm Chris Lai. I'm from CPP Hyperloop. And today we're going to be doing a workshop on 3D printing 3. So this is a workshop on troubleshooting your 3D printer based on all the issues it can have, including filament issues, adhesion issues, and whatnot. And we're also going to be talking about the CR Touch and how to use it to level your bed using the 9-point method instead of doing it manually using the screws under the bed. So today we're going to go ahead and do a mixture of PowerPoint presentations and live demonstrations all in a 1-hour time span. Let's get started. So adhesion issues. Most adhesion issues comes from the fact that the bed is not leveled correctly. So the calibration of the bed is really important. So it's very good to note that when you're first printing something. Let's look at the picture on the right here. This picture is an image of a print that has been printed when the nozzle is too high. When the nozzle is too high, the filament tends to drop onto the bed and it doesn't create that nice little layer you see like on the bottom here. Like, this is a perfect print. You see how all the little lines that are being printed are very close to each other. There are very little gaps and the filament sticks to the bed as the nozzle is moving around. So you got to watch out for not being too far from the bed. Now, I understand some people like to do this because it's a safety measure. It's like, okay, I'm going to ensure that the nozzle doesn't crash into the bed by just putting it a little bit too high. And that's completely fine. There is a sweet spot in which that does happen. But in general, you don't want to make sure your nozzle is too high when printing. Now, on the contrary, you don't want the nozzle to be too low either because you don't want to ruin your bed by pushing the nozzle all the way into the bed and moving it around there. That can ruin the bed, first of all, because you're literally stuffing a 220°C nozzle into a bed, a 60°C bed, and the materials don't like that. So you got to find the sweet spot, and we'll talk about how to calibrate things later. So for the calibration of bed, the most important things to note are to A, check the nozzle height, B, view the bed from the horizon level, and C, tune your CR30. Should be CR Touch. CR30 is something else. We're going to tune our CR Touch settings mid-print, and we'll talk about that later. So if you don't have a Creality-based printer or Ender 3, you don't have to do this step. There are auto levelers for other types of printers, and it's not just centered around Creality, but those may have to come with their own different softwares and different firmwares as well. So the view bed from horizon level is important. When you get really good at printing, as with like working with any other machinery, it becomes less standardized and more like you can feel when things are right. And this just comes from experience. So most of the time, 3D printers are equipped with the 4-level or 4 points leveling method, where it asks you to put an A4 paper underneath the print bed and shift it around. And it asks you to do for one corner and then the next corner and then the next corner and then the next. But sometimes that's a little bit too vague because you have a billion other points in the middle that you're not sure if they're level or not. And usually the leveling process takes a long time. I remember when I had my first JG Magic printer, I've had to go through this a lot because I didn't know the correct method to do it. But there is a setting on the 3D printer called Disable Steppers. And if you turn that on, it allows you to move all the parts around freely. So what you do is you go ahead and move the Z-axis manually until it gets to that point where you can stuff an A4 paper under it. And then you look down at the bed horizontally and manually move the nozzle to all 4 corners and level instead. And since you can move the bed and the nozzle to all different points, it allows you to make sure that all 4 points are level with each other, in addition to the middle parts as well. So just make sure you have all around method of leveling. And I'll demonstrate this a little bit later, but generally, the disable stepper setting is only something that you use when you're like really comfortable with the machine. You got to kind of manhandle it a little bit, just to get it to do what you want, what you want it to do. So first layer issues, we're going to go over this. So depending on your material of bed, your first layer issues are going to vary. Now, the three main materials I have experience with myself are sticker beds, well, not materials, but different kinds of beds. So sticker beds are the cheapest. Then you have magnetic beds, and then you have glass beds. Some people also choose to print on an aluminum plate, like an aluminum hot plate. And that's fine. So like they print without a bed. And this is fine with like very cheap printers. Cheap printers only have the aluminum bed. They don't have anything else on it. But there are specific things you have to watch out for if you're doing that. So sticker beds are the cheapest type of bed. They're about $6 on Amazon right now. I don't know if it's inflated or not, but sticker beds are cheap. They are pretty effective. They offer really good adhesion for PLA. And just like they're really good all around in general, because if you mess up on a sticker bed, it's easily replaceable. Pretty cheap to replace. And I really suggest you keep like maybe a fodder bed around or a buffer bed, just so that in case you mess up, like during a first print, you put that bed on there instead of your like nice glass bed. So that once you get your calibration settings right, you can just go ahead and swap the beds out. And so you have like one really trash bed, and then your neat bed is, your neat bed comes after. And it's really nice to have a neat bed because the bottom of prints is a big quality factor when it comes to getting your prints to work. So if the bottom of your prints is really nice, then it's just like a plus to your overall print. And the bottom of the print only comes with having a nice and clean bed. And so first layer issues come with that. Magnetic beds are more expensive. I'll talk about that for a second. It's pretty much the same material as sticker beds usually, but you can pop them off easily because they're magnetic and they can stick to the aluminum plate. Most creative printers come with this. Most other printers do come with this as well. It depends on the size of your bed though. So that's one parameter you kind of need to make sure you have. Glass beds are the most expensive one out of these three. The Ender V2 actually comes with a glass bed by default. I just don't like using glass beds because the adhesion is a pain to work with. Now, the adhesion to the bed comes with the fact that the bed is porous. So if you like zoom in really close to the bed, it has a bunch of little holes in which it kind of like has a vacuum effect and sucks the filament down and prevents from moving. However, glass beds have the least adhesion out of all the three kinds of beds, and you usually need some additional method to stick the prints on. Same with aluminum, by the way. So the additional adhesion I would suggest for that case would either be glue sticks, hairspray, or NPA. Now, the problem with glue sticks and hairspray is that they both make the underside of the print look terrible. They are a cheap and effective way to make 3D print stick. If you got a bit of money to spend, I would suggest, of course, NPA, but hairspray is also a good option because it doesn't make that effect on the bottom of the print as much. NPA stands for nanopolymer adhesive. So like this stuff, oops. So nanopolymer adhesive is a brand of adhesive produced by Vision Miner. It's a blend of chemicals stuff. That's the best way I can explain it. But it's designed for high temperature build plate glue. And so if you apply this on like a bed, you don't actually feel it. From experience, I've applied this onto my CR30 belt printer, and you don't actually feel the adhesion, but the prints do. And so this is kind of like your last resort. It is pretty expensive. I think this bottle of 100 and, how much was this? Well, 150 milliliters was about $50. So it runs you up money, but this bottle is supposed to last you 6 months with the regular printer. Of course, I have my big printer, so about a fourth of the bottle is already gone. But it's pretty expensive solution, but it works. It makes the bottom of your prints look really clean, and prints come off really easily. It's just that when you're using something like this, you got to be generous and cover the entire build plate. So don't try to skimp on this stuff, yeah. So another first layer problem that exists, if you're using a CR30, this exists less, but if you're printing something really wide, something that might happen is you're going to see a gradient. So a gradient is when you have very nice layer on one side of the bed, but then you go to the other side of the bed and you see that all the prints have been stuffed inside of the bed. So like one side is higher than the other. And this is just a basic calibration issue that you can fix by doing the disable steppers method. And finally, beds get dirty a lot. So if you see on the bottom here, this print is good, but like the bed is like really dirty. And this is, I think it's a Prusa printer. And this happens because of the when you take prints off, some of the print still lies on the bed and you kind of need to clean that off. So best way is to use IPA, which stands for isopropyl alcohol, to do so. And isopropyl alcohol is a really good way to clean your bed, but also a really good way to remove adhesion. And although this stuff, this nanopolymer adhesive, is made using alcohol, alcohol actually removes any adhesion you have from the bed. So you got to apply your glue stick, hairspray, or whatever if you want it to stick again. And it's just like a precautionary measure. Okay, so when dealing with a new printer, first clean it with IPA. If the bed is a sticker bed or a magnetic bed, you don't have to do the step because those usually offer good adhesion right out of the box. And if you actually put on IPA, it might make it worse. But if it's a glass bed, that's what I would suggest you do because glass beds are kind of random and kind of sporadic in nature. Okay, let's move on to the next slide. Filament issues. Let's talk about filament for a second. So I've run into many issues before in which filament becomes a hassle to work with. And I've tested many brands. These are the top 5 name brand options on Amazon, all with like around the same price point, about $20 to $30 per kilogram of PLA or whatever else material it might be. Of course, different materials will be more expensive. PLA is the most cheapest. But the 5 ones I want to talk about are Overture, Sunlu, Hatchbox, Creality, and Amazon. Now, you see that I've highlighted Amazon in red, and just from experience, Amazon is the worst out of all of them. And this happens because it just snaps in like 10 billion different places. The tensile strength is just trash. And the prints come out pretty nice. But just like because of all the other issues, when you're printing, you want it to go autonomously from like the start of the print to the end. You don't want to intervene too many times. So having a roll of PLA that doesn't snap in the middle and have you trying to replace it in the process is a plus. And definitely something you want to avoid is Amazon Basics. It's not even the cheapest one out of these 5. It's just bad in general, and I don't know why Amazon decided to make brand of themselves. If you've had a positive experience with Amazon, that's great, but I'm just bashing it just off of experience and the fact that in general, some of the other companies make better quality PLA. And so the top 4 here, we've Overture, Sunlu, Hatchbox, Creality. In experience, the best PLA I've ever used comes from either Creality or Hatchbox. And by the way, the Creality PLA is actually the cheapest one out of these 5. It comes at around about $14.90 per roll if you buy it off their website with free shipping. And here's the secret, right? Usually you want to buy, usually you're tempted to buy PLA from Amazon, but I've learned that PLA from Amazon only works for like other types of PLA, like TPU or ABS or Orbium. I don't know if they sell Orbium on Amazon. I don't think they do. But Creality is the cheapest. It works the best so far. Hasn't snapped on me yet. It's just all around good in general. And I know Creality is going to have some pretty good PLA because they are the company that makes all the printers. And so Hatchbox is your next best option. If you have the money, Hatchbox is about $8 more expensive than Creality, but it does top it in quality. The prints come out really smooth, like silky smooth, and it's amazing. So Hatchbox is the next one I recommend. Now, Overture and Sunlu, I have a love-hate relationship with, and if you ask some of my friends, they do as well. Overture has not snapped for me yet. Actually, just kidding. Overture has snapped on me. I just checked my printer over there, and the roll of Overture filament I have has snapped, so I'm going to go ahead and replace that later. But Overture is good for TPU, and TPU is a type of elastic filament that only works if you have a direct drive printer. Direct drive printers mean that instead of having the extruder stepper motor on like the side of the printer, you have it right above the nozzle. So it feeds the filament right to the nozzle instead of through a Bowen tube to the nozzle. So the Bowen tube is like the little clear tube from the extruder stepper motor from the side of the printer to the nozzle. So Overture is good for TPU. I'm not putting PLA as a recommendation just because some of my friends have had bad experiences with it. And Sunlu is good for PLA plus, but you got to watch out because filament has a shelf life like any other thing. And if you don't put it in like a moisture controlled environment, I'm stealing that word from one of my friends, but if you don't put it in some kind of controlled environment and the temperature around it is volatile, the print filament can actually snap and clog up stuff and just have a different chemistry in general. So if you're not using filaments, you should store it in some place dry and just somewhere that's not going to be affected by temperature much, like a closet. Closet's the best way to store PLA. Or they sell some of these really expensive $40 incubation chambers for PLA, which I find really funny. You can find them on Amazon. So things that filament can do, they can snap mid-print, clog up your Bowen tube. It can set too fast or slow, and it can mess up your smooth layer transitions. And so smooth layer transitions is something that you can fix in Kira or you can fix during hardware. There's a lot of fixes you can try with your 3D printer. And so pretty much snapping mid-print is a hard one. I'll show you guys some ways to prevent that. And oh, one more thing I forgot to put on here. Filament can get dusty. If you're hanging your filament above your 3D printer as you try to print it, it's going to collect dust. So you're going to need some sort of dust filter that attaches itself onto the filament roll in order to just siphon out the dust as the filament goes into the machine. And this is really effective, by the way. It helps your prints and prevents dust from getting onto your prints. Okay. So troubleshooting. Now, a few ways to troubleshoot your 3D printer, and it's really important that you learn how to actually do this. Of course, you can kind of phone a friend beforehand, but during the troubleshooting process, you want to ask yourself these questions. So where is the problem in general, right? When someone gets a 3D printer problem, they always have to find out where the problem is. So if the problem is in one of the stepper motors, go check out the stepper motors. If it's near one of the beds, then check out, the screws under the beds, make sure it's calibrated. But you don't want to get flustered when you see a problem because usually there's a good solution to it. You may not find it for a couple hours, but there is a reason why it's broken. So where in general is the problem? What could cause this problem? So is it a Cura setting that you messed up? Like maybe the flow rate was set to 200% instead of 100%. Is it a tightening measure? So because of the Ender V2s, you can tighten both the X and the Y axis and tension them accordingly so that the belt is tight enough. Is it maybe some kind of filament issue? Maybe you need to replace the roll of filament and it's good to go. Maybe it's the fact that your nozzle is clogged, in which you can just replace the nozzle. But best advice I can give for troubleshooting is have patience, because troubleshooting can take a long time, and it's no use raging over some sort of tiny little mistake like I have done in the past. So patience is key when working with machines. And next question, why could this happen? Which part needs working on, and then go deeper from there. Each printer is different. Each printer, although it's made the same, using the same parts, is different in nature. Some work out of the box and some need a lot of work on. And so you just got to treat some of these printers like your own children in a way. And you got to treat them well, and they'll treat you well back with good prints. And one more thing I want to talk about is that there's no harm in a reset. So there are times where I have worked on a printer and I've worked on it so long that I've put in so many different settings that it becomes confusing. I've added so many variables into the mix that I'm not sure exactly where the problem is. So there is no harm in just doing a complete reset, completely removing all my changes, completely resetting the firmware from the website, calibrating the device all over again, and then start from the beginning and test each step to be right. So from that point, you can start over pretty much. And the next time around, maybe you have more experience from your previous attempt, and then maybe you can just avoid some things you know you messed up on and get to a success condition easier. Okay, so at this point, I want to go over some of the download methods. If you have a Creality printer, which I'm going to use for the demonstration of this workshop, you can go to this download page. And if you're using any other printer, they should have some sort of firmware download page. If you're using something like a RAM board, like a custom board, I think you can flash some Arduino software on there and get your printer to work. But the core basis of all microcontrollers that are inside of the 3D printer comes from the fact that it has good firmware. Now, there are different types of firmware. You have the default ones. Let's say if I go to Ender series firmware, I have an Ender 3 V2, so I'm going to click on this. You can see there's a lot of different ones. And based on your main board version, you can choose a different type of software to download. And you can notice that it says compatible with BL Touch and filament detection. So we're going to take a look at the BL Touch later on today. But it does require new firmware, which can get confusing based on the type of printer that you have and the version of motherboard that you have. So if you go ahead and check out the motherboard, on the Creality printer, you unscrew the bottom and just like look at it. There should be a version number. Now, the latest version of the motherboard for these Creality printers are either 4.2.2 or 4.2.7. If you have an Ender 3, like the regular one, like an Ender 3 Pro or Ender 3, it has a motherboard that's like 2.0.6. This is like the one I have on my Ender 3. And the motherboard has not been upgraded yet. So basically, what I'm trying to tell you is that the motherboard version is very important. If you're trying to do a full reset, you want to go ahead and maybe do something like these two. By the way, touchscreen firmware. Each touchscreen or each screen you have actually has its own firmware that you can flash. There's an SD card on the screen you can push an SD card into just to re-download the software all over again. Because the screen and the main motherboard of the 3D printer are two different types of devices that communicate through each other over UART. So you may have to download like two separate softwares just in case, but we're going to talk about the main board right now. So if you don't have a CR Touch or a BL Touch, you can go ahead and click on one of these links. I'll send you to a zip file, and you can download this. And all it contains, I'm going to download this just for example, and just to show you guys. If we go ahead and extract all the compressed folders from here, let's just extract this, and then go ahead and find the correct folder. Okay. Opening the folder, you can find a bunch of Marlin versions. And these Marlin versions, Marlin is just like the name of the firmware they give it. The motherboard version is different. Marlin is just the person or the company that made these files. So let's say original firmware, right? We click on the original firmware and we get a bin file or a bin file. And all you do is you take the SD card that comes with your printer, you put it into your computer, you drag this bin file onto your SD card, and then you just put that SD card back into your printer. And if it's the correct file on boot, the printer will automatically recognize this is an execution file or a bin file, and it will run the contents inside of it. So if I click on the bin file, you can see that it's a bunch of garbage that we can't understand. But the printer understands this. So it will go ahead and run the stuff inside the bin file, and then it'll load your new firmware. Now, depending on your version of 3D printer, it may have an EEPROM or it may not. So depending on your printer, it may save things on the printer itself or save things on the SD card, which is important because these settings will be saved on your SD card and not on your printer. So let's say I have calibrated my printer to have a Z offset of -0.4. If I want to save these settings on on a printer that does not have an EEPROM, it's going to save onto the SD card. So the next time I want to turn on the printer, I need to make sure I have that SD card inside the printer already, because all the settings are on the SD card itself. So you want to have the SD card ready, because in case it didn't save onto the motherboard itself, it'll read off the bin file or the settings that are on the EEPROM.dat, that's the file it's called, and then it will reload the settings all over again. But if you plug in the SD card after you turn on the printer, it may not save any of the settings. So you got to be careful in that way. Some printers do have a save and load setting that's already built in onto the programmer or the microcontroller, but some printers don't. So just to be safe, you want to check for that EEPROM.dat file. And I'll demonstrate that in a second. So let me go get my SD card for my printer over here. So some of these printers have SD cards, regular SD cards, and some have micro SD. I think the new Ender 3 series printers have micro SD cards. Let's see, in which you'll need an adapter for. So let me just plug this in. Hello. Seems like it's not working. It's like getting caught on something on the inside. Let me try a different SD adapter. One note about micro SD adapters, actually. Sometimes you may see that the Creality printer you just bought comes with one of these SD card converters. Now, these white ones are basically just an SD card on the bottom connected to a USB on the top. These suck because there's a high chance that this might not work. Always go for the SD card if possible. This is a micro SD to regular SD card adapter, and plug this into your computer, because there's a high chance these may fail. You always want to go from this to your computer because it's safer, it's more direct, right? It doesn't have to go through a conversion. But I have a bunch of these just hanging around from all the CR30 printers I've worked with, or Creality printers. Creality printers and Ender 3 printers are made by the same company, so you can just say one name for both. Okay, let me check my storage for SD cards. Let's see if this adapter works. Okay. Yeah, it does. I think this one just was jammed. Okay, let's see. See if it connects. Come on. It's making me look bad here. I'm just kidding. Let's want to connect.
Playing from MSI.
Thank you, Alexa. Very cool. I heard the noise. I definitely read something. Let's see. I don't think I read it as an SD card. Okay. I'll deal with that later. Some issue to deal with the fact that it's not reading things. Okay. With that then, let's move on to the demonstration portion of this workshop and take a look at the physical model of 3D printers. Okay, switch webcam. Here we go. All right. Choose video filter. And pin this. Okay, so this is a Ender 3 V2 printer. Let me go ahead and turn it on. And attached to this is the CR Touch. Now, before, as I mentioned, the CR Touch does come with some pretty clear instructions on how to use it. The important thing is that the firmware download comes from the website. So you should see a very long loading screen the first time you download the firmware, because it's going to be loading things up. And let me see if it saved anything. So notice how, I don't know how good the quality is, but okay, you can't see it, but the Z offset settings loaded, so I know the printer can read the SD card. And I can see all my files on here too. So the V2 comes with a very slick screen that you can use to control the settings and visualize different things. And it's also a silent printer. So the new year comes with a lot of different technologies, one including silent printer technology. So in the motherboard themselves, they have different routing systems in which they use to silence the stepper motors so that it's not really loud, as some old printers used to be. And so these printers are so quiet, you can have them like in your room, out and about, and just be doing things, and it'll just print. All the noise actually comes from the fans. And sometimes these fans get clogged up, so you need to clean them out a little bit. So one big change that a CR Touch changes to a printer is that it moves the homing position from a corner of the bed to actually the center. Because the CR Touch goes ahead and lowers itself onto the bed. And when the plunger detects that it has hit the bed, it just retracts immediately. Okay. Now let me demonstrate what a homing process looks like. Even with the CR Touch, just keep in mind that you need to have all the bed relatively level so that the plunger can do its job. If the bed is not relatively level, which it does happen out of the box, like you can't expect the printer to work as soon as you take it out of the box and assemble it. Sometimes the bed will come very unlevel and the CR Touch will not want to work. So just as a precaution, there is an option on here called Disable Stepper. It's on every single printer. Just find it, click on it, and then you're able to move all these stepper motors around freely. So here's the X-axis, the Y-axis, and the Z-axis too. And what I like to do is I like to take a piece of A4 paper. Where's my A4 paper here? So I like to take a piece of A4 paper and lower the Z-axis. So the Z-axis is behind here. So lower it like this. And it doesn't have to be very exact. It just has to be like around. Oh, you see like how you can push it too far in, and then this nozzle moves, or the gantry moves. Okay, it just has to be approximate. Okay. Now you can get rid of the paper because the rest of the operation comes from practice. You're going to need a lot of practice leveling it because you can start to see exactly when things are leveled and not leveled. So I'm going to simulate what happens if you're looking at a printer from a side view. So this is what I call horizon view. You're looking at it from the very side, like a side angle, and it's even lower than this actually. You're looking at it perpendicular to the nozzle pretty much. And when you do this, you're able to see any discrepancies that happen when you move the printer nozzle. So let's say I want to go to a corner first. So let's say I move the gantry over to this corner. And the point I want, or the location I want, is going to be similar to the center here. So I see like the center has a little bit of, I guess, white space or clearance from the bed. So I want to replicate this in the corner. Now I can see in the corner that this center space is a little bit too low, or like there's not enough. So I'm going to twist it a little bit just to make sure that the clearance appears. Now, I noticed that it's a little bit complicated with me explaining it, but it gets better with practice. All you want to have is that you want to move this around and have the space between the nozzle and the bed even across the entire bed. And you don't want to do this with an A4 paper because sometimes the paper might be a little bit inaccurate. So you want to trust your senses. So trust yourself in this, and you get better as the more you do it. So you move it to the next slide and you say, okay, it looks about the same. I can move it back and forth just to make sure the clearance is the same. And then I can move it from front to back. And it seems like the bag is has too much clearance compared to the other ones. So I'm going to just lower it a little bit. Okay, and then just push it to this side, and this side is way too low, right? So I'm going to turn it to the left to increase the clearance, and move it back. I'm going to decrease this clearance. Okay, and you can see here how I'm just like moving it from corner to corner and just watching the nozzle and the bed, because the clearance between those 2 points will allow me to see exactly if the bed is level or not. And remember, if you're using a CR touch, it doesn't have to be very exact. It just has to be approximately right. Because sometimes what happens is that you get your printer and then your printer turns out to have a bunch of leveling issues. And it's exactly because of this reason. So the stable stepper is a very nice trick to compensate for this. Okay, so once you're done with the leveling, you want to auto home it. Now, I already know my Z offset for this printer. The Z offset should stay constant throughout the entire printing process. It's basically the offset from the bottom here to the top. So you're giving the little mechanical plunger an offset based on what it detects to where it's going to print. Okay. So I already know this offset is negative 1.15, but let me go ahead and fix this issue right here. So if you notice on here, this printer has overture filament, and the filament has actually broke. And it's because I haven't used this printer in such a long time. Printers usually break filaments based on the fact that they're under such high tension all the time. So if I go to another printer, maybe like this one, you can see that the filament is hanging from the roll to where it's being inserted. And this part has a lot of tension. And because of the tension, it's prone to breaking, right? If you have enough stress, it will break over time. Same for this one. So I have a white roll of filament here. This is actually pretty new, so it's not going to break because it has such a wide range. However, this roll of filaments is very close to running out, which is why the closer it is to the center of the reel, the more likely it will break. So let's do a complete printer filament fix. What you want to do before you do anything is you want to first go ahead and preheat your PLA. I'm going to turn on this printer as well. This printer is the one that I actually own. And this printer has a white filament, which I like because it allows you to see exactly what it's printing and what it's doing at every single point of time. So I'm going to go ahead and preheat this one as well. Okay, so from the first 2 printing workshops, you should have heard Alex talk about something like a calibration print. There are many types of calibration prints out there, including a calibration cube and the 3D Benchy. The Benchy is a torture test, what's commonly called, for the 3D printer. It's a little miniature ship that has a lot of edges and ridges and overhangs to test the printer's flexibility when it comes to those things. So theoretically, your printer should be able to print around at like a 45-degree angle, given its supports. And the 3D Benchy really allows for that to happen. However, if you don't have a Benchy, what you can do is print one of these cubes. This is a calibration cube. It is a 20 millimeter by 20 millimeter by 20 millimeter cube, and I have a bunch of these. And these are really nice for making sure that your printer has a good X, Y, and Z axes all around. And so I can provide the STLs for both of these prints in the description of the video once I find them. And also, I want to talk about this little device over here. So the device on the side of this printer right here, this is a filament duster. So as the filament passes through this device, there's a little cotton ball inside of it that just takes the dust off any filaments. And it's the same for right here. It's a pretty cool device, actually. If I show the camera here and open it, you can see that it captures a lot of dust, right? A lot of dust that would have gone into my 3D prints if it hadn't gone to this device. And so this is a single piece. It's printed using PLA, and has a very little support structure inside, so that it's bendable. And so this just snaps around itself, and you put a cotton ball inside of it, and then you place it around the filament, and then you close it. Okay, so this printer has finished preheating, so I'm going to go ahead and remove the filament. Now, the Ender 3 V2s have a little knob here, a little blue knob that you can use to twist out the filaments. And so you can see here it broke again. So the tensile strength is very low. You just gotta hope it doesn't break on its way out, because then you would have a little bit more of a problem. Okay. Sure gets all the way out. Okay. So I'm going to go ahead and recycle this filament. And just so that in the future, if I ever get one of those machines that you can use to recycle filaments, I can reuse this again. But for right now, to replace the filament, it's really easy. You just gotta grab more filaments, stick it in the hole, and since you have this little blue piece here, that's supposed to help you insert the filament inside. Go. It is a little bit annoying sometimes though, because sometimes it just doesn't want to go in. Come on. And I can tell you, this is like probably the most infuriating part, because I've been here for like 20 minutes at a time sometimes, just trying to get this little piece inside. Okay, I'll deal with this later. Sometimes it just doesn't want to go in. This is exactly why I have the secondary device here, which is the printer that prints white filament instead. Okay, so I'm going to do a demonstration print of how the CR30 starts printing, and then I'm going to go over how to find the Z offset of the CR30. How much time do I have? 15 minutes, good enough. Okay, so if I print, I preheated this, and let me just print something fun, like, where's my benchy prints? Okay, I will print. Okay, so I don't have a benchy print in here. Should have a benchy print. I always have benchy prints. I'll print the top. Okay. So since I preheated this printer, it doesn't have to go through that process when it starts again. So it should automatically recognize that it's at 200 degrees and go ahead and start printing. And you'll find out that when you print a lot of the process is in the waiting. So you have to wait for. Oh, you can see here the white film is coming out. It's a lot of waiting, even if it's like already preheated. And I suggest carrying one of these air compressors around with you, just so you can spray every once in a while, because it does get really dusty, especially if you're in the room with it. Did you know that human skin creates dust pretty much? So you, in fact, are a very dusty person. And that dust gets on printers. Like if you have a CR30, which is a belt printer, that dust gets sucked in. The CR30 is like a dust vacuum almost. Okay, so watch what the printer is doing right now. This is a command called G29, which is located on the Cura setting. So if you have to initialize a printer, you have to first slice the STL and then put it into like a slicer like Cura. Change the settings. So this is in the initialize settings in Cura itself. And G29 takes a measure of all 9 corners of the bed. This is the quote unquote auto leveling process that the printer takes when printing something using a CR Touch. It has to take data from all 9 corners. Then it creates a kind of matrix of all your different points and all your different points on the plane, on the XY plane, so that it can create some kind of mesh to linearize all the different printing points so that your print comes out very smooth and flat. If you have something like Octoprint, Octoprint is it's an OS for the Raspberry Pi that allows you to visualize your 3D prints as they're happening. So there's an extension for the Octoprint that allows you to see this mesh, see this 9-point calibration in action and tell you if your bed is really level or if it's not, and how your printer is compensating for that. It's a really nice little graph that you can see. We might go over Octoprint in some later workshop, but as for now, this is all we're going to be given. So as you can see, once the printer head has finished all 9 points of calibration, it's going to go ahead and do an initial line on the side here. And again, because this is a white filament, it's really easy to see if you messed up or not. So you can see all the little imperfections on your bed here. This is just from the NPA. This is the only bed I applied NPA to, just as a test. And you can see here, this line really tells you a lot about how the print's going to go. You want to go ahead and feel this line. Just a bit of warning, the bed is at 60 degrees Celsius. So just be careful not to get burnt. It does get a little warm, but you won't get burnt. So feel this line. If it's smooth, that means your nozzle has no problems. Also, you can go ahead and, so this is something I like to do. I like to go ahead and peel this line off because it tells you if your bed is correctly calibrated or not. If your nozzle is too close to the bed, this line is going to be really hard stuck to the bed. If it's really too far from if the nozzle is too far from the bed, this line is just going to come off. So you have to find that sweet spot. Again, a lot of what 3D printing is just feeling. You have to feel if something's right or not. And so you can see how this print is just a big, it's a big top for one of my projects. And you can see how if I feel across this initial layer, it feels very, very solid. Now, the nozzle should be a little bit pressed into the bed, or not pressed in the bed. It should be slightly pressed so that it squishes the PLA. You don't want to have a circular hemisphere of PLA that surrounds this area. And so it's going to keep on printing. I'm going to stop it in a little bit because I don't want to keep on going. But this is what a perfect first layer should look like. And maybe I'll come back to this in a little bit. But let me go ahead first and talk to you about how to make the Z offset work for a CR Touch. Now, the Z offset is something that's a little bit hard to understand. So first, you need to go ahead and recognize what is called absolute positioning and relative positioning. Now, the Z offset calibration uses something called relative positioning, which means that if you change something after you've done the initial Z offset calibration, it's going to go ahead and take that as a relative position. So it's going to create the new setting based on your old setting. So if you have a Z offset of -1.15, and then you calibrate again, and you find out that it has a Z offset of -1.14, and you set it back, the Z offset is going to add those two together. So you don't want that to happen because it's going to crush your bed. So what happens if you mess up during a Z offset calibration? The best thing to do is to start over. So I'm going to go ahead and start over to show you. I know my Z offset right now is -1.15, so I can always go back to it later. Remember, the Z offset for a printer should never change once you install CR Touch. The Z offset really changes based on the CR Touch, actually. So let's go ahead and first home the device. Now I know there's no filament in here, but we're just going to go and pretend there is. And just looking back at the other prints, you can see that design has been made. And sometimes when you have a lot of intricate designs on your board, which is why I wanted to print this out to show you. This is a top module for one of my projects, which is the SDVX board, like a sound voltex board. It's a rhythm gain controller. So the rhythm gain controller has all these different kinds of ports for the switches and all these ports for the holes as well. These are screw holes, actually. And this is a hole for the potentiometer. So it has a lot of precise movements that the printer needs to make in order to print this out correctly. And in order for this to be successful and your first layer to be successful, you need to make sure that these squares are not loose. They're actually stuck into the bed. So like if I rub it a little bit, it's not going to come off. And trust me, like the first time I printed this thing out, it didn't go as successfully as this. But once you get your calibration settings ready for the printer, the rest of the print should go as smoothly as just turning it on and activating the print. Like you don't need to level it, you don't need to do any kind of intermediary action. And once you install an Octoprint on this thing, it'll become even more autonomous, which is good. Because all we want to do is we want the 3D printer to make money for us. So it just keeps on printing, it keeps on printing, and all we need to do is give it the STL and it just completes the rest. So let me go ahead and reset the Z offset to 0, just to show you. So on the LED screen, I don't know how clear this is to you, because I know that these LED screens don't like to work sometimes. But I'm going to reset the Z offset to 0 and go closer. How's that? Okay, you see the Z offset is going to go to 0. Okay, now the Z offset is 0. I'm going to go ahead and auto home it to reset everything. Okay, now would be a good time to talk about the differences between the CR Touch on Ender 3 Pro and Ender 3 V2. Note that this demonstration is for Ender 3 V2. The process on calibrating the CR Touch for the Ender 3 Pro is a little bit different, but the relative positioning is the same. So it's much easier on Ender 3 V2, by the way. What you want to do is once it's finished homing, go ahead and go to Move, and you'll see that Move Z, this Move Z option here, by default, it likes to calibrate itself about 10 millimeters above the Z axis. So again, use the horizon line, look at it from a perpendicular angle, and take the Move Z and move it all the way down to 0. On the Ender 3 V2, it does not let you push the Z to a negative value. So you got to do that from the Z offset. So at this point, what you can see is that the nozzle is not close enough to the bed. So to account for this, we have to use our calibration paper again. Now this is just to find the Z offset. Of course, you can use something like the tune option in the middle of a print, just to make sure that your Z offset is very nice. So you can see here when I put my calibration paper under the nozzle that there's no resistance, which is not good. So what you want to do is you want to go back. You want to go to the Z offset. And now you can move the Z offset to your desired position. So I'm going to go ahead and move the Z offset. And remember, it's negative 1.15. So I'm just going to do it negative 1.15. And so you gradually lower the Z offset. MSI. Oh, thank you, Alexa. You gradually move the Z offset down until you start to feel some resistance. And so there we go. All right. And once you have set that, you can just go ahead and auto home. To verify that you have gotten the Z offset correct, go ahead and do the same steps again. So once it's finished auto homing, go back to Move, decrease the Z all the way down to 0, and then take a look at if the nozzle is close enough to the bed. If it's not, then you got to change something. So I'm going to go to Move, now that it's auto home, and I can see that the Move Z is actually at 11.1, which accounts for my Z offset. So theoretically, if I move the nozzle all the way down to the bed, it should be correct now. So it moves it down 11.1 millimeters. And I can see from the side that the nozzle is hovering over the bed. Now, there's a difference between hovering and being stuck into the bed. So be careful of that. You want to make sure that the filament slightly drops itself onto the bed, but not too far so that you get print errors. So now that I have the correct Z offset, I can go back and start printing something. However, because of the filament issue, I'm not going to do that. One last thing before I end this workshop. If we go back to this print, we can see that it's printing pretty successfully. This first layer is pretty smooth, right? We want smooth first layers. All the little switch holes are pretty solid. It's getting pretty hot here. Now let's say you're starting a print and something's not right. Let's say you have a adhesion issue with CR Touch. How do you change that? Well, most printers have an option. Let me zoom in real quick. That's called tune. So you have tune, pause, and stop on here. But tune is on the left. I apologize for the bad quality, but I don't know how to make this a little bit better. So under tune, there's an option for Z offset, which you can change the Z offset live while it's printing. Now, this is a really good, useful way to modify your Z offset because sometimes you may be like 1/100th of a millimeter or 2/100th of a millimeter off. And it would be really nice if you could just go ahead and quickly change that without restarting the entire print. Well, you can. So go ahead and select the option and change the Z offset while it's printing. And you can then fix your prints without having to restart it. And sometimes, like when you're beginning to start printing, that's a big issue. All right, so now that I have gone through all of the fun little steps it takes to 3D print, I'm going to go ahead and stop this because I don't need this part. And this has been a demonstration of how to use the CR30 when printing, and also calibrate your printer and find the Z offset. Now, I'm going to go ahead and return to this video later and put some links in the YouTube description of this website to some little tools I would like to recommend while 3D printing. You can see here that if I zoom in onto this board, the first layer is very smooth, attached to the bed, and it doesn't use adhesion. Now, all these beds use sticker beds. Although the Ender 3 V2s did come with glass beds, I found the adhesion too hard to work with. So I just went ahead and used these sticker beds instead, and they have been perfect this time around. Now, magnetic beds are also nice, but they're a little bit more expensive. They come out around $11 per piece. If you're lucky, you can find them out for less. But you know, just for the sake of what I have already, I already have sticker beds, so that's why I'm using it. I'm going to remove this print using a spatula. And when you're removing it with a spatula, you don't want it to be too hard. You want it just to come right off. So for this first layer here, I can just like give it a good shove underneath and just take this entire piece off the bed. And these parts are not going to go to waste. They're going to go into my recycling bin, in which I'm going to one day reuse this PLA for something else. So for those of you who are watching this video after it's been posted out to YouTube, please check the description for some links that I suggest where you can get some of these printing tools and printing materials, and also start printing stuff of your own. So thank you for watching. I hope to see you in the next workshop and hope you learned something from this one. Take care.